Hi there. Hope you have a fantastic day today. This lesson, I will go through 2023 HSC paper with you. Of course, there's a PDF versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Question 14a, part 1. So in order for f of x to have an inverse functions, so f of x must be one-to-one functions. In another word, f of x must be always increasing or always decreasing in this domain here. So keep that in mind so it doesn't have any turning point. So let me just differentiate f of x first. So f of x is 2x at Ln of x. So if we differentiate this, f of x will give me 2 plus 1 over x. So this means that when x is greater or equal to 0, so we can see f of x is always greater than 0. So in another word, the functions is always increasing for x is greater than 0. Okay, so therefore, f of x is, so f of x is one-to-one functions. So therefore, so there you go. Part 2. So let g of x is inverse of f of x by considering the value of f of 1, or otherwise evaluate g dash 2. So first of all, let me just work out f of 1 first. So we know that f of x is equal to 2x with plus ln of x. So therefore, f of 1 is equal to 2 lots of 1 at ln of 1. And we know that ln of 1 will give me 0. So therefore, this will give me 2. So in another word, g of 1 is equal to 2. Because for inverse functions, we just swap between x and y values. So keep that in mind. So this means that g of 2 is equal to 1. So g of 2 is equal to 1. So in another word, f inverse of 2 is equal to 1 because f of 1 is equal to 2. So therefore, the inverse functions that is passing through 2, 1. And now we need to find the gradient of the inverse functions at x is equal to 2. So therefore, we can find the inverse function of this, and we differentiate that and we substitute 2 in to find the gradient of the inverse functions at point 2, 1. But it's too difficult to find the inverse functions. So what we can do, we can find the derivative of the inverse functions in terms of y. So let me do it. So we know that y, let's f of x is equal to y. So that is 2x at ln of x. So this means that x is equal to 2y plus ln of y. So I just differentiate of the inverse functions in terms of y. Okay, keep that in mind. So now I differentiate this. So that is dx dy is equal to 2 plus 1 over y. So if I simplify this, this will give me I times y on 2. So that becomes 2y at 1 over y. So that is dx dy. And one of the differentiations of the inverse function property is this. dy dx is equal to 1 over dx dy. So that is the differentiations of the inverse functions. Okay, this is one of the property. So this means that dy dx is equal to y over 2y plus 1. So this is the differentiations of the inverse functions in terms of y. And we know that it's passing through 2, 1. That is the inverse functions passing through point 2, 1. So we just need to find the gradient of the inverse functions at that point. So that means when y here is equal to 1, so we can find the gradient of the inverse functions. So that is dy dx is equal to 1 over, so 2 lots of 1, because y is equal to 1 at 1. So that means 1 over 3. So that is the gradient of the inverse functions at point 2, 1. So that is g dash 2. So that is, therefore, g dash 2 will give me 1 over 3. So there you go. Part B. Consider y is equal to 1 over x and x minus c all square plus y square equals c square, where c is a constant. Part I. Show that the x-coordinates of any point of intersections of the hyperbola and the circle are zeros of the polynomial p of x is equal to this. So when the intersections, so this means that we just solve it simultaneously. So let me just write this down. So we know that y is 1 over x. So what we do, so we just substitute y equal x into this function here. So that is y squared will give me 1 over x squared. So this means that we just substitute y squared into the circle functions, x minus c all square, and we add y squared. So y squared is 1 over x squared is equal to c squared. Now what I do, I just remove the bracket first. So we just go x squared and x times negative c is negative cx, and we double it. So that gives us minus 2cx, and we add c squared, and we add 1 over x squared and is equal to c squared. And don't forget, this c squared we can cancel out, so that is equal to 0 here. And I times every term by x squared because I want to get rid of the fractions, that is the x squared. This x squared here, I want to get rid of it, so I times every term with x squared. So that will give me x power 4 minus 2c x power 3. So don't forget, I times every term by x squared. And that will give me 1 is equal to 0 times x squared is equal to 0. So therefore, p of x is this, x power 4 minus 2cx power 3 plus 1. Let me check. So there you go. X power 4 minus 2cx power 3 plus 1. That is p of x. So there you go. Part 2. So we need to solve for c. That is when the hyperbola graph and the circle intersect at one point. So we know that when they intersect at one point, so in another word, this graph here, okay, only cut the x-axis once, okay? So in another word, the turning point is right on the x-axis like this. So this means that y is equal to 0. So that is x-intercept, okay? So y is equal to 0. And y dash must be equal to 0 because this is the turning point. And we must follow these two conditions. So let me just write down y and y dash first. So we know that y is, so that is y. And then we need to find y dash. So y dash equal, and y dash must equal to 0. So when y dash is equal to 0, so this means that, and to solve for x, so I just take out the common factor. So that is 2x squared out. So that will give me 2x minus 3c. That equals 0. So that means x is equal to 0 or 2x minus 3c is 0. So therefore, 2x is equal to 3c, x is 3c over 2. And we know that x must greater than 0. So therefore, x is equal to 3c over 2. So we need to substitute x is equal to 3c over 2 into y. And then this means that y will equal to 0. So must follow this condition here. So that means 0 is equal to x power 4. So that means 3c over 2 power 4. We minus 2c and x is 3c over 2 power 3 at 1. So now let me just expand the brackets. 0 equal 3 power 4 is 81. C power 4, 2 power 4 is 16 minus 2c and 3 power 3 is 27, c power 3. 2 power 3 is 8 and add 1. So let me just simplify further. So 0 equal 81 c power 4 over 16 minus, so these two here cancel with this, give me 4. And c times c power 3 is c power 4. So that is minus 27 c power 4 over 4 plus 1. Now I just times 16 because I want to get rid of the fractions. So times 16 with 0, and that will give me 81 c power 4 minus, so I times 16 here, so that give me 4, and then with double 27 is 54, double again 108. So 108 c power 4, and we add 1 times 16 is 16. And let me just collect these like terms. So I just go 81 minus 108. That is negative 27. So 0 equal negative 27 c power 4. We add 16. And I move the negative 27 c power 4 on the other side. So 27 c power 4 is 16. And I divide everything by 27. C power 4 is 16 over 27. Now we just take the 4 roots on both sides. So we know that c must be greater than 0. So therefore, we just ignore the negative. So that is c equal 4 root of 16 over 27. So c equal 4 root of 16 over 4 root of 27. And 4 root of 16 will give me 2. So the answer is 2 over 4 root of 27. So there you go. And thank you so much for watching. Bye.